teaching. So I started recording. This is motion of a skydiver. I already did this. I already did this once in O level. And what am I doing over here exactly like that? I'm going to take this theory test again on Monday. Remember that. Okay. If you guys don't give me this properly, okay, I'm telling your parents not to send me in my tuition. Khalas. I don't want. If you guys cannot learn it and give it me by this thing, other people, you guys should on your webcam and keep. I'm bar bolte see. You should on the webcam. Then you're going to write the test in front of me. Okay. The motion of a skydiver. Okay, now let me explain this properly and in detail. O level you guys did, but I think O level I did not do much detail, maybe 60 to 70%. Still 20% information was remaining. Focus. Yeah? Focus. Okay? Okay. Let's say an object is thrown from a helicopter. Okay? When you throw the object, initially, just the moment object was thrown, the only force acting on this object is its weight. Understood? There is no air resistance because air resistance starts acting only when object starts moving. If it moves, then only air resistance starts acting over there. Otherwise, it doesn't. So initially, what is the only weight? Sorry, only force acting on the object? The weight of the body. Okay. Because of the weight is the resultant force over here. What is the weight? Weight is the only force, right? So this is the resultant force acting. So the object is going to now accelerate. What will happen? The object is going to now accelerate. When the object accelerates, what happens? The velocity increases. Yeah. And when the velocity increases, that means your air resistance also starts acting on the body. So if I draw, this is snapshot number 1. Let's go to snapshot number 2. Same diagram, but this time you have your weight, but you also have a bit of, you can see the arrow of air resistance is less than weight. You have a bit of air resistance over here. Okay. Before, what was the resultant force? What was the resultant force before? The weight. Now, what is the resultant force? The resultant force is it's accelerating downwards, right? If you guys see my video, which I did regarding resolving forces, if you guys see my video over there, you will notice whichever side acceleration, that side we take positive. So in this case, your weight will be positive, and whichever side is opposite direction of acceleration, here acceleration is downwards, it's falling downward, na? So it is accelerating downwards. So whichever side you have acceleration downwards, you have air resistance. Okay, opposite. So air resistance is negative. Can you see? Okay, that is the resultant force, and resultant force is M into A. Can you see, compare it to before, your overall resultant force has decreased. Before it was only weight. Now weight is there, but from weight, what is getting subtracted? The air resistance value. So your overall resultant force has decreased. Understood, everyone?
Yes.
Therefore, your air resistance is there now. You have acceleration. Wait 1 minute. You have your acceleration, but your rate of acceleration will be less than before. Before, your acceleration was very high. Why? Because your resultant force was high. What happened now to your resultant force? The resultant force decreased. Since the resultant force decreased, your acceleration, it is accelerating. Sorry, it's not that it is slowing down. The object is not slowing down. It is accelerating. It's like a car. Imagine a car is going, its speed is increasing, but its speed is increasing very quickly. 0 to 10, 10 to 20 immediately. But now what happened? Basically, it is accelerating, but the rate of acceleration has decreased. Is it clear with all of you? Everyone?
Yes.
Okay. So now since the resultant force has and বললো টিচারের কাছে পড়তেছি সে তো আপনার সঙ্গে অনলাইনে ক্লাস করলো সকালে
No, I was studying there. She was asking what were you doing? I said I was studying.
Studying where?
In my room. She thought that I was doing online class.
না সকালে আমার সাথে কোনো অনলাইন ক্লাস ছিল না, ও আমি ওকে জিজ্ঞাসা করছি, ও বলছে ও তো পড়তেছিল যে হ্যাঁ ওকে পড়তেছিল, আপনাকে বলছে পড়তেছিল, কিন্তু আমাকে এখানে কিছু দিতে পারে নাই। ওকে 30 রিয়ালের ল্যাপটপটা কিনে দিয়ে।
Hi.
Okay, so now the speed is going to increase. Listen, Bhaiya, you said the acceleration is decreasing. Why is speed increasing? It is still accelerating, na? I told you, right? Initially, it was accelerating very highly. The rate of acceleration was very high. Now, since the resultant force has decreased, your rate of acceleration has also decreased, so it is still accelerating. Velocity is still increasing. Air resistance will also still increase. Okay? Now, what will happen after this at third snapshot? Let's talk about third snapshot. At third snapshot, your arrow, the length of the arrows will be same of both of them.
Bhaiya,
Wait 1 minute. Hai bolo.
okay. Does in the second snapshot the acceleration decreases or increases?
Acceleration decreases because your resultant force has decreased. That is the reason.
Okay.
But your velocity will still increase. It's like, as I said, 0 to 100 you went very quickly. Okay, but from 100 to 120 you're accelerating, but you're accelerating slowly. Understood? But in both the cases your velocity is increasing only, na? You are not slowing it down. Your velocity is increasing, right? Understood?
Yeah.
Understood? Okay.
Yes.
At third snapshot, after some time, your air resistance is equal to your weight. That means your resultant force is now 0. Total upward force is equal to total downward force. The body is in equilibrium. When do you call your body is equilibrium? When the resultant force is 0. Or we can say it's a balanced body. We can say it's a balanced body, because why? Your total upward force minus total downward force will be, the resultant force will be 0. Okay, so when a body is in equilibrium, it is traveling at constant velocity. Therefore, your acceleration is 0. Remember, at constant velocity, acceleration is 0. Everyone understood?
Yes.
Okay. Okay. This is a special name. This constant velocity has special name. It is known as terminal velocity. Okay. I hope all of you understood till here. All these theories, I have this in recording though. All these theories is given here, over here. Number 1, before the parachute opens. 1, 2, and 3. Snapshot 1, snapshot 2, snapshot 3 has been given to you. Since I'm recording, let me just put it over here. Whoever seeing this video, just pause it and see the see. Okay, let me go to the next paragraph.
Bhaiya, can you go to that
And see. Wait.
your snapshot one?
Yes. Okay. Now, tell me which snapshot do you want to see?
Snapshot 3.
Snapshot 3. Check snapshot 3. Any questions you have from here? Let me know. Do you have any questions?
No.
Okay.
But can't I relax?
Are you feeling cold?
Medium.
Okay, done.
Sorry, he wants more AC. This guy.
Sit here.
Table to the knees.
No. Okay, let's go. Now let's see new snapshot. What happens after the parachutes are opened? What happens when you open when you have an open parachute? Basically, let's say the skydiver. It's a skydiver. It's an object, whatever it is. Now suddenly let's say the parachute opens. Okay, don't laugh at my parachute. Okay. Okay, this is a parachute. Okay, in parachutes, your weight is just like before only. If your weight was 52 Newton, now also it is 52 Newton. Okay, like that. But what will happen due to the parachute? What will happen? The air resistance increases significantly because the surface area is more. There is more drag. Recently, we learned the word drag. Okay, air resistance is very, very high. This is your air resistance. Understood, everyone? So your weight here is less than your air resistance. Okay, now the resultant force is in upward direction. The resultant force is upward direction. The object is moving in this direction, but the acceleration is in opposite direction. Therefore, we will say negative acceleration. Okay, object is moving downwards, but the acceleration is upward. We call it negative acceleration. So the only name we can say, this is decelerating. There is a deceleration going on. Why?
Bro,
Yeah, tell me.
how did the acceleration change from downwards to upwards?
Okay, because before, okay, here can you see the both the forces are equal to each other? Let's say suddenly the parachute opened. That circle thing you see is parachute. I'm sorry for my diagram. This is parachute. Tanisha, can you help me here?
Yeah,
This is
sure.
this is a parachute. Okay, understood, na? You got the idea, na?
Should I draw?
No need, no need. You got the idea, na?
Yeah,
Okay. So due to the parachute, there is going to be drag, na? A lot of air resistance. You see the arrows I gave over here, lots of arrows in this region. And because of that,
yeah,
your air resistance is now more than the weight.
yeah,
Okay. So that's why I wrote weight is less than air resistance. Your resultant force is now in upward direction, right? Before here, initially, your resultant force was downward direction. Initially in this snapshot 1. So it was accelerating downwards. Now it is accelerating upward. Okay. But the problem is, yes, I know it is accelerating upward. But what is its motion? It is still moving downward only. Now, because of the parachute, it is not going upward. The object is falling still downward only. But the thing is that now it is falling with less speed. Why less speed? Because the object is decelerating. Decelerating due to what? Due to the parachute. Understood? Kainat, Tanisha, Ahmad, understood?
Yes, yes.
Yes,
Everyone?
yes.
Okay. So now the object is now decelerating. That means it is slowing down. If it is slowing down, the velocity is decreasing. We know velocity. If velocity is decreasing, your air resistance is also decreasing. Okay. At one point again, let me copy paste this. I don't want to draw this again. My beautiful masterpiece.
It looks like a broken umbrella.
It looks like a broken umbrella. Whatever it looks like. Okay. Okay. Same diagram I'm doing right now. Okay. But this time what I'm going to do is the air resistance will be equal to the weight. The air resistance will be equal to weight. Why? Your velocity is slowing, your object is slowing down, and you know air resistance is directly proportional to velocity. Okay. So if if velocity is more, air resistance is also more. So here your velocity is decreasing. Why? The object is decelerating due to parachute. So at one point, again, your air resistance will be equal to your weight. This is what we call terminal velocity number 2. Okay. It is traveling at constant speed again. Everyone understood? And we call it terminal velocity number 2. Number 2 velocity. Okay. After that, the person can land. Okay. Now tell me one thing. I really wanted to make the class much more interesting rather than the boring. I'm pretty sure some of you guys are bored over here. Okay. I can see some of your face and I can feel that vibe is coming that you guys are bored. I'll be showing you a jump. Okay. There was this person who jumped 39 kilometers above Earth. How many of you saw that video?
Space.
I
Basic.
saw a video from space. The guy was jumping.
How do you feel that they are bored or not?
How can I feel they're bored or not? Voice. Pujde.
If you both the same meaning,
No, our voice is dead.
Yeah, I know they're bored. Kainath, aren't you bored?
and you only see my
I know. I don't think so. Kainath is bored. Kainath nowadays she's taking a lot of interest in classes. Okay, Tanisha, are you bored? Ola,
No, I'm okay.
Ola, are you bored?
I'm hungry.
He's hungry.
Me too.
Okay, okay. Let's see. No, let's see. Bada.
Mhm.
Ahmed, are you bored?
Nope.
Yes. That's the spirit. Okay, I'll show you those all of them now. First of all, what else is there? Yeah, you guys need to see the graph. First of all, you guys need to see the graph. So initially the lines are straight because it's accelerating. It's a velocity time graph. So you're accelerating, but after one point, your this one start bending. Why it is bending? Because after this point, the air resistance starts acting. So you see, I told you now the rate, it was supposed to continue like this straight line, but it's not accelerating forever like that. Initially, the only weight was acting in this region. Therefore, it was accelerating. But after that, the acceleration decreased. Why? Because air resistance. As the more the velocity, more the air resistance. And after some time, it reaches constant velocity. And this is terminal velocity number 1. Here, you have terminal velocity number 1. After that, suddenly the parachute opens. If the parachute opens, sudden deceleration. There is a sudden deceleration. Okay, not this quickly though. It will take some time, deceleration. Okay, and after some time, it reaches terminal velocity again. This is terminal velocity number 2. Everyone understood the graph? I'll show you guys the graph now. Just have a read at it. All of you, whoever got this file with them and whoever doesn't have the file, please let me know. Let me know. The name of the file is All Physics Unit 1 folder.